the guys that are running deep into the eights are in the 900, probably to 1100 horsepower range. If the Supra's DI injection alone can support, let's say, 550 horsepower without port injection, we're only supplying another 500 or 600 horsepower. So, an ID 1000 or an ID 1300 or whatever injector people are using is pretty much large enough to get you up there.
Welcome to the HPA Tuned In podcast. I'm Andre, your host, and in this episode, we've got Jake from Motiv Motorsport with us for a chat. Jake and Motiv Motorsport in particular are filling a really niche void in the tuning market, providing a separate standalone controller to add port injection to a direct injected engine. And you might be thinking, well, why do we need such a device? And the reality is that unlike port injected engines, when we start making more and more power with a direct injected engines, injector size upgrades are just not that simple. Not like the port injected market where we can go to a range of suppliers and just buy a larger off-the-shelf injector. That is much trickier with DI engines. So most people get to a certain point and then they start adding port injection as well to supplement the direct injection. Now that's fine if you're adding an aftermarket standalone ECU, but of course with our modern vehicles, the GR Supra for example, which uses FlexRay communication between the different electronic modules, is really difficult to strip out that factory engine management system and fit in aftermarket. So that's where Motiv's Reflex product comes in. Now, initially, when I started researching Jake and Motiv Motorsport, the product itself struck me as being something of an oddity because I know when I'm tuning, I like to be able to do all of my tuning in the one place. And when we're adding an auxiliary module to take care of the port injection, I was sort of thinking to myself, well, that sounds like it's going to be pretty hard work on the dyno. I'm going to be tuning the factory engine management system, and then I'm going to also be tuning this Reflex unit as well. Interesting chat with Jake though, finding out how deep they're going into integrating that particular product into the way the factory engine management system works, and then with help from the aftermarket Reflash platforms, they've now got support where there's two-way communication between that Reflex device and the factory engine management system, giving some safety backstops and also allowing in some instances all of the port injection control to come from the factory engine management system, which kind of answers one of those questions we often get asked: at what point is the factory engine management system not up to the task? That answer is getting more and more difficult to give as time goes on because there really are simply so many solutions now that there's not a lot the factory ECU can't do. Currently, Motiv's Reflex product is powering most of the fastest A90 Supras on the drag strip well into the 8s, and that really goes to show just how effective this product is. Our chat with Jake also goes really deep into how he got started in the industry, because we often get asked how to break out and get started learning how to become a tuner. So we follow Jake's story right from the start up to where he is right now. Before we get into our chat with Jake, just a quick introduction to High Performance Academy. If you aren't aware, we are an online training school. We specialize in teaching people how to tune aftermarket and factory engine management systems. We also cover performance engine building quality and reliable wiring harnesses. We also cover race driver education, car setup, data analysis, and even fabrication. You can find all of our courses at hpacademy.com/courses, but really relevant to today's topic is our tuning suite of courses. This includes our EFI Tuning Fundamentals course, which will teach you all about the fundamentals of EFI tuning, how the ECU works, and how an engine management system works, how to decide on the correct amount of fuel and the correct ignition timing to deliver to your engine. We've also got our Understanding Air-Fuel Ratio course, and this is one of the most misunderstood topics, I believe, in the world of EFI tuning. You only need to ask on any enthusiast forum, what air-fuel ratio should I run? And you're likely to get as many different answers as you have people contributing to that thread. This course breaks down all of the misinformation out there and gives you solid facts, solid starting air-fuel ratio targets so you can get your engine up and running without risk of damage. Then, most importantly, we'll teach you how to find the optimal air-fuel ratio for your engine and application. Then, lastly, we've got our 2 practical application courses. Practical standalone for those of you running aftermarket standalone engine management systems, and our practical reflash tuning course, perfect for those of you reflashing the factory engine management system, which is really the basis of most of today's chat with Jake. Now, I'll put a link in the show notes to all of those courses, and as a bonus, as a podcast listener, you can use the coupon code podcast75 at checkout. That'll get you $75 off the purchase of your very first HPA course. All right, with that introduction out of the way, let's get into our chat now. All right, welcome to the podcast, Jake. Thank you for joining us today. And I want to get started by learning a little bit about your background, how you got involved with engine tuning, how you got up to the point of founding Motiv, and basically everything in between. So yeah, let's go back in time a little bit. What's your background? How did you first get involved in the automotive industry?
I would say it's a lot like, from the stories that friends and I and the industry have gone over. It's pretty similar to most of us. We got cars when we were younger and we broke them, and it got expensive to fix them. So it was either fix it yourself and learn, or, get a second job and try to do it. So along that process, it made a lot more sense to figure it out myself and learn through my own mistakes than to pay somebody else to do it and have, no more knowledge under my belt to get there.
All right. Let's talk about the sort of cars you're involved with back in your sort of earlier days. You're known for the BMW and the A90 Supra platform at this stage, but what were you playing with? You sort of a BMW guy through and through?
No, I actually started my first car that I had that was mine and not shared was a 2006 Mazda 3. And maybe 3,000 or 4,000 miles into it, after throwing a 35R on it and blowing my second motor, I figured it was time to sort of dive deeper into it. So that's where I started with the E6 and the E8s and learned to play with it a little bit more. And
we're talking Haltech product here.
Yeah. And once the engine stopped breaking and, the power is being made well, then I was going through gears and having to get billet gears made and learning to do it myself. I mean, it saved 50% of what it costs to do the actual modifications. Once you have the product, then it's another X amount of dollars to get it installed. So shade tree mechanics at its finest, a couple jack stands in your townhome parking lot, and 3 days later and a couple angry neighbors and you're good to go.
The torturous and expensive path of learning to make power, I think it's one that a lot of us have gone down. It's a deep rabbit hole, but once you're hooked, it is what it is. I must admit, I felt sure for some reason that you were going to, like 99% of the guests I've had on this podcast so far, say that you started in the Honda platform. So actually quite refreshing to hear something new.
Yeah, I've never actually owned and modified my own Honda. It was my first was the Mazdas.
Okay. The skill sets required here. So I'm guessing you've got no formal qualifications in the mechanical industry? Is this
Correct.
Self-taught?
Correct. I'm actually military healthcare by trade and background in education, so quite different, but this was my outlet.
So if you cut yourself while you're working on your car, you're good to go?
I do more brain injury, but I have friends at the office that would be able to help.
The two elements of modifying modern vehicles with electronic fuel injection, there's the mechanical aspect of working on the car. That's one side of it, but there's only a handful of people sort of tend to veer over to the other side of the tracks with the fuel injection side, and that for a lot of people, and I mean this is one of the reasons HPA was founded, is because it's difficult for people to learn those skills. So I'm interested in how you develop that skill set.
Mine was sort of pull the pin out of the grenade and throw it and hope to survive.
Okay.
But mostly just trial and error. We would try something, and we had, Facebook groups really started it. Having friends who were modifying the same car, but doing themselves because we were in school and, budgets were tight. We just sort of shared experiences, and over breaking your own cars enough, or sharing success stories, as well as failure stories, you sort of just pick up on it. A lot of it came through just tinkering and sitting on a dyno and, if I change this table, what does it do compared to if I change this table? And you sort of take notes, and eventually, I don't want to say it's riding a bike, but eventually, you find the patterns that work.
You just mentioned dynos, so I take it you had access in those days to a dyno, which would be certainly very helpful, but also not specifically usual or typical. How did that come to pass?
There weren't many people being as irresponsible with Mazdas as I was. So the car caught a little bit of attention. I think it made like 210 horsepower from the factory. And once I had built the motor and set everything up, it was making about 650 to the wheel on race gas and about 725 when we would really turn it up on ethanol. And there wasn't a lot out there. It still looked like a 4-door sedan with no stickers, well, at this point, it didn't have any paint job or anything like that. It was just stock wheels and a loud turbo that surprised people.
Okay.
So, we would go to, back in the day, it was called the Towers Meet in South Florida in Fort Lauderdale. And, people would see the car and get impressed. Shop owners would come by and be like, oh, that's pretty cool. Who built it? And, it's one of the things I love about our industry is when you go to these meets, it's really not competition. It's camaraderie. It's bonding over different tastes with the same background or interest. My Honda's fast, my Mazda's fast. It doesn't matter. I mean, we're all really just trying to do something unique and express ourselves.
Yeah, no, absolutely. I mean, it's one of the elements that I think makes the whole automotive scene so interesting and appealing to so many people. Now, you mentioned the Haltech. Was that the tuning solution you're using on your Mazda?
That was the only thing that was really available back then.
Could you just remind me what generation, what year are we talking for this?
This was
Mazda?
a 2006 Mazda 3. So it was actually right before all the Speed 6s and the Speed 3s came out with turbos. This was just a naturally aspirated little 2.3 liter motor. And those didn't hold boost very well for long, at least.
In terms of tuning solutions, was there anything at that point that allowed access and tunability of the factory engine management, or were you restricted to standalone?
Standalone. And even the standalone wasn't a standalone. It had to be run in parallel. There was no designed kit for the car. So whatever standalone I was using was wired in to control everything I needed it to, while the ECU of the car still thought everything was, status quo.
Yeah, I was going to say 2006, not that I'm familiar with that Mazda platform, but, past, give or take, around about the year 2000 is when things for us in the aftermarket started to get increasingly difficult, and there was this communication between different electronic modules. I mean, these days, obviously, things are significantly more complex with multiple CAN buses, but upshot of it was made it harder and harder to remove the factory ECU and make the whole car work. So you're only using the Haltech to control the fuel and the ignition boost pressure, I'll assume. And basically, as far as the factory ECU considers, everything's just happy days, and it's still running a 2.3 litre naturally aspirated engine.
Yep. Still thought it was MAF instead of blow through. Still thought, it was never seeing positive pressure. So it was happy as can be with an open loop fuel system, really not providing too much feedback to change anything.
Harder to do that, though, strategy on anything like relatively modern, correct?
It's increasingly harder with all the, with everything being closed loop these days. As soon as you change something, a engine fault comes up or something goes into a limp mode because, the parameter is 0.1 lambda or 0.01 lambda outside where it wants to be.
I had this exact scenario in a Vision 11 Subaru STI I tuned back when those were relatively new, and it was for a client over in New Caledonia, and they happened to be an HKS Pro dealer, so they had to use the HKS FCON V Pro, which is a weird little piggyback unit. I don't much like them myself. I found them frustrating and difficult to use. However, I digress on that element. The thing was that because it's piggybacking the factory ECU is still seeing the output from the wideband air fuel ratio sensor, which it only uses under idle cruise conditions. It's open loop under full load, so that element's fine. But the problem is you could tune this thing to the best of your ability, and it didn't matter who you'd give it to. And if you sat there with the car idling for a period of more than about 5 or 6 minutes, unless the air-fuel ratio was bang on 14.7 to 1, or actually cycling backwards and forwards slightly across that, even if, as you say, you're 0.1 out with your air-fuel ratio, what happens is the factory ECU, the closed-loop control, would start adding or subtracting fuel as required. Obviously, it would make no difference because it's no longer controlling the fuel. So over a period of time, that would step up or down to the minimum or maximum plus or minus 25%, sits there for long enough, pulls a diagnostic trouble code, and in that particular car, I can't remember, it actually caused a drivability issue. So these are the things that, and I mean, the Vision 11 STI is by no means a modern or complex vehicle, but I mean, just to show the sort of element of complexity that these piggyback systems come into, and this will become more of a relevance as we go through today's discussion. Let's move forward a little bit, and as I mentioned at the start, you're best known for your BMW mark and support. So how did you make the transition from fast Mazdas to BMW?
Just by chance, I moved up to Virginia out of Florida, and a good friend of mine back then owned a company that modified and made hard parts for the BMWs. They had a piggyback system that they had created. And with my tuning background, when I was now local to him, he was like, hey, why don't you come work on the BMW platform with us and see if we can advance it a bit? So I sold my Mazda Speed 6 back then. I picked up my first 335 and sort of off to the races.
So for tuners, and I've been in this situation myself, it can be daunting and complex to sort of basically close the door on everything you know on a given platform and start from scratch on a new platform. So how did you approach that? How steep was that learning curve getting into the 335i?
Every car is different. Every brand is different. But once you have the knowledge of, what it takes to tune, I mean, at the end of the day, and not to oversimplify it, it's all airflow. It's an air pump. It's bring air in, put fuel with it, pump it out. Either, naturally aspirated or boosted, it's still all doing the same thing. And we have been very fortunate that, as our company developed, a lot of the tuning platforms were developing simultaneously. So we were able to keep very current and make sure that we always had the latest tables, and make sure we were always playing with the newest abilities of control, so that we were never falling behind. We were always sitting on that cutting edge. And even today, I mean, every day new things are coming out, new technologies changing, the flash platforms are growing. There's so much more that we can do with these companies than ever before. So it's always just about staying current. It's always about, reading what other people are doing and how it's working, and where there's failure points and what they've learned. Because, I mean, you look at an ECU and you break it down, there are thousands and thousands and thousands of tables, most of which don't need to be touched. And it's helpful to have a tight-knit community where we can bounce things back and forth. And especially with us, we have two calibrators at Motiv, and another individual who used to do a lot of standalone support and IMSA racing. We have a lot of brain power to bounce things back and forth between. So it's not just one person trying to figure out. It's a collective to go over what we've learned, how we learned it, and how to implement it going forward so that our customers get the greatest experience. Okay.
And now, in those earlier days when you just started, getting into that BMW platform, what were the tuning solutions or tuning platforms that were available? I on a side note, sort of the European market, the European tuning market has usually been one that's a little bit unique in so much as the European tuner specializing in Volkswagen, Audi Group, BMW, Mercedes, etc. The majority of them basically use a tuning solution for reading and flashing, and then maybe the likes of WinOLS, a binary editor, for actually finding maps. And that's a skill set that is quite different to the actual tuning process. So that's not for everyone. What we really want as aftermarket tuners ideally is a nice software package that already has a definition file that finds the fuel and ignition maps, just for simplicity's sake, inside of that raw binary file. So what was available when you first started?
So, when I first bought my first 335 in 2009, maybe, we only really had, I want to say it was the Proceed. And that was another piggyback style, ECU that people were using. And, as I said earlier when we were just talking, it worked. But to say it was good or anything like that, it's a stretch. And what really changed the game was Cobb came out with the first flash platform, and it provided that package that you mentioned. And there were other piggybacks along the way. There were, multiple companies made different little plug and play harnesses that allowed you to trick sensors and change things and control things. And they made power. But did they do it the right way? In my opinion, no. So it's not something I would want to use. But come along with Cobb, now we've got access to all these tables, and they've defined things, and it allowed us to finally control these cars through actual table management. We're not just skewing parameters or tricking sensors. We are setting closed loop targets. We are adjusting what the ECU is commanding the car to do and using the actual feedback to achieve those results. And through data logging and remote tuning, we were able to reach a larger community than just the people around you. It was no longer, I can tune, come drive 200-300 miles and we can tune the car. It's, oh, you're in Germany. Oh, you're in France. No problem. Here's how you log. Here's my instructions. Send me the CSV file and I'll return a file to you, a little bit later, and we can dial the car in specifically for your needs.
Okay. There's a bunch of stuff that you've just talked about there, and I want to just head back and unpack a few of those elements. So let's just start here with a little bit more information around a piggyback. So we already had the example of your Mazda 3, where you're essentially using the Haltech to completely control fuel and ignition. So that's one element of a piggyback system. Back in those earlier days, the factory ECUs were dumb enough that you could get away with that, and we've used that technique in the past to get around interaction between a factory engine control module and a factory transmission control module. So we can fit an aftermarket standalone, control the engine perfectly, and the transmission will still shift. So that's one element. I've already talked about as cars have become more complex, that's getting harder. So some of these piggyback modules, though, are a little bit simpler. We're not talking about a full standalone. We're talking about a module that basically will intercept the likes of the signals going to the injectors and can either shorten or extend the pulse width that the factory ECU is providing, maybe essentially doing the same for ignition timing. So it kind of gives us a way of fooling the factory ECU, actually in that respect, we can also fool the sensor inputs, maybe the mass airflow signal or coolant temperature or something like that, to basically try and get the result that we want out the end. But it's it's a bit of an ugly way. It's sort of sticking a band-aid on the problem rather than a true solution. And of course, again, as the computers become more sophisticated, they're self-monitoring. A lot of these ECUs run closed-loop fuel control everywhere, including under wide open throttle. So unless you can actually change the closed loop target, which you mentioned, you can tweak it a bit, but the ECU kind of just learns itself around what you're trying to do and gets back to the same situation. So these piggyback modules on at least the current generation of cars, do they have a place? Or are they completely useless now, completely redundant?
There is a place for everything in the world. That's one of the things that's great about this community is there's so many different ways to do things, and who's to say who's right or wrong? I have strong opinions, and for customers who ask my opinion, I will share it with them privately. But there are benefits, especially with ECU technology getting so stringent now and rolling codes that make encryption or de-encrypting so difficult, and being able to write these ECUs in the certain spots that need to be written for the maps to be programmed. They're also not able to be accessed right now. So a new car comes out, a piggyback can be thrown on it and it will work. Again, is it the way I would do it? Probably not. But first to market, these guys can make power faster, and that's what we all want. We all want to go faster. So yeah, I mean, the place is maybe being first to market, since there's no encryption to overcome, or table finding and putting together the software suite that allows calibrators to go in and do things. They can just put the product out until that comes along, and then the momentum shifts more in favor of the flash platforms. It's no longer a piggyback because that's all that's available. It's, well, now I can actually control this ECU.
Yeah, that makes sense. I think as well, I'll just add in here, from my perspective, a piggyback controller does have its place, but I think where people get in trouble is when they try and go beyond what the product was designed for. So I'll give an example here. We used a very basic piggyback controller on some of the naturally aspirated Honda Civics, Integras, B18, B16, Type R, that sort of thing, where in stock form, the common modifications would be maybe an intake, headers, and an exhaust system, which doesn't really put the factory calibration massively outside of the range it was in factory trim. So we don't need to make huge changes, and a little bit of a tweaking to the fueling, maybe a little bit more ignition timing, maybe a change of the VTEC point, that actually probably got 98% of the benefit that we would get from going to a full standalone. So happy days, worked really, really well. However, where I also saw problems was with people trying to then use that same piggyback controller, but add 1,000cc injectors, a set of really aggressive cams, and a turbocharger. And while I can't say that you couldn't get the result with that sort of modification, you're really trying to perform surgery with a meat cleaver, essentially. It's not going to be a pretty result, and not what I'd recommend. So just to give a bit more kind of like a more rounded view on piggybacks, because as you say, they do potentially have their place.
That's part of the problem with it, though, is that it's scary in that sense, is because, especially with the internet now and everybody having forums and Facebook groups, I could look right back at you and say, but Andre, I saw this guy online who did it and it worked perfect. He made 1,000 horsepower. Yeah, he did. And he ran a 9-second pass down the quarter, but you didn't see a second pass where the bottom end fell out.
Well, I'd say even apart from that, that's fine. And dyno figures have become increasingly used as a tool for selling products or tuning platforms on the internet, and to a degree rightly so. The problem is that unless you've got a drag car, in my opinion, the wide open throttle performance, first of all, it's actually the easiest part of the whole tuning process to get right. It's very basic, and even the most basic ECU can normally do a pretty stand-up job of that. How did the car drive to the track? Did it start at minus 10 degrees C in the morning when there's snow on the ground? These sorts of things. How does it idle? And for a daily driven street car, that is, in my opinion, so much more important. And that's where you require really good control that you're almost certainly not going to get with a basic piggyback.
I mean, you mentioned cams earlier. You're not going to be able to adjust the air and the fuel at idle for a set of Lopi cams. You're just going to get it until the short-term trims peg, the long-term trims start to adjust, and either you're going to run into a fault like we had discussed earlier because the ECU just has no more range to adjust, or if your ECU isn't even that smart, you could run into failure because it just has no more fuel to throw at it or able to compensate for the massive amount of air change that you brought in. Yeah.
Unfortunately, these are the elements that we've just discussed that you don't get to understand from looking at a dyno graph or even a run down the drag strip.
No.
Now, moving on, you also mentioned remote tuning or e-tuning, and this is something that it's a whole industry essentially that's cropped up, and it's got a really checkered reputation, unfortunately, as well. Obviously, there's tuners like yourself who understand what they're doing and will be tuning out quality tunes for customers. But unfortunately, because of the relatively low entry point in terms of cost, you don't need a dyno. There's a lot of people who have popped up and maybe aren't getting those sort of results. So for a start, can you maybe just give us like the 30,000 foot view of what e-tuning actually is and how you as a tuner are doing this?
So with the ability, as these platforms have progressed, and I'll start with Cobb back in the day. We were able to capture all of the data and record it so that our customers could, head down a private road in Mexico and do a completely legal poll and gather the data and send it to us in a file that allowed us to interpret everything we would normally have to have, an O2 sensor at the exhaust tip and a torque curve to see if there was any ignition issues. It allowed us to compact that into a package that didn't even need to be mailed. It was just something that they downloaded, and all of a sudden, every single person had the power in their pocket to send all the data needed to complete a Well, I say all the data. The majority of the data needed to complete a calibration. So with that, in the early, I would say the late, I guess they call it the aught years, all the way up to 2010 plus, it really began the trend of expanding our services beyond our geographical locations. We could now tune in California from the East Coast. We could have a customer in France who, had a dyno available to him and could get all the stuff. And in a 2 or 3 hour session, we could knock out a full tune that allowed the car to perform not just how we wanted, but, with feedback from the owner, how they wanted, how the pedal would be, feel for them, how the car would drive, how it would perform, and on a cold day with ethanol, still be able to start. And these were all things that we couldn't do prior to these platforms being able to collect so much data.
I think a lot of this is also driven by the advances on the OE platforms, because back when I first started tuning, the stock ECUs and even the aftermarket of the time were very limited, and the likes of wideband air fuel ratio sensor, that wasn't the norm. In fact, almost unheard of. NOx sensors as well, aftermarket ECUs, very few of them, if any, had onboard closed-loop knock control strategy, so you weren't able to actually know when knock was occurring. And likewise, I wouldn't strictly trust some of the OE knock control strategies at the time either. But these days, particularly with cars that are running a factory wideband air fuel ratio meter, so you can log that, exactly what the air fuel ratio is. The knock control strategies are becoming more and more sophisticated. You can log so many parameters at a sufficient speed, so you're no longer really blind to what's happening. Is it sort of really not too much different now to being in the car, in the driver's seat on a dyno?
Exactly. I mean, it allows us to look at all of the data. Like I mentioned, the power of all the data that we used to need, whether it be, having a Plex knock sensor mic on the engine, or all the different tricks and tools we use to monitor. It's all logged over OBD2 now. So with that in mind, we could safely tune somebody's car. It wasn't just, we're going to do this because we know it works on our cars. We're actually responding to the data that's being thrown into the log in every sense of how the engine's performing. A lot of these cars have calculated EGTs. They've got airflow. They've got all these readings that allow you to really map out what's going on, so you can truly make changes based on data and not just based on the customer saying, I heard something clunk in the engine as I was shifting, or there's a little bit of lag between the shift. They can give you that feedback, but you can look in the log and plot everything against time and RPM and see how long that shift was, and see what ignition was doing at that shift, and seeing what airflow was doing at that shift to find out, why was there a lag and how to, sort of replace it. There's torque limits that come into play, and different reasons that ECUs pull torque from the drivetrain. And all of this data is just available in a small CSV file that takes 30 seconds to email to us.
In terms of you providing a remote tune like this versus tuning that exact same vehicle in person on a dyno, what would you say you're getting in terms of results? So are we talking it's going to be the same? Go chuck it on the dyno, it'll make the exact same number that it would if you were tuning it in person, or are you providing just a little bit of a wider safety buffer because you're not with the vehicle?
I am a very conservative individual by nature. So when I'm tuning a vehicle, I usually pull that last 5% out anyways when I'm done. But I've noticed over the years that when a customer finishes a street tune over the internet with me and either comes back to me 6 months later or a week later and says, "Hey, I'm going to be on the dyno. Do you have time to take a log? Look at a log between pulls. I get three runs to map." I'm always happy to look, and I would say collectively over the years, we would probably feel we're within that 5% range where we can get it near perfectly dialed in. Now, does a dyno allow you that last little bit of extra comfort to really see what's going on and looking at the plot and seeing if there's anything that looks out of it? Yeah. But I mean, I would say safety wise, we are confident that it's not an issue on the street and e-tuning. Performance wise, we're probably that little 5% extra more cautious, but I think customers appreciate that in the long run because, while everybody does want that last bit of horsepower, the difference between that 5% and that, even if you're at 500 horsepower, you're talking, 25 horsepower. You don't want to waste the money. You blow your engine, there's $8,000, $9,000, $10,000 because you wanted that extra 25 horsepower. And the street data, it's sometimes actually better. It allows us to see the actual conditions that the customers are running. It allows us to see the load that the car is providing on the actual street with the actual heat or moisture in the air, as opposed to, even though dynos are great with eddy current brakes and can provide great simulation, nothing really beats actual data on how the car is driven like it is driven on the street by the person.
I'm really glad that you brought up that point because that is so often overlooked. And throughout my career, I've made a point wherever possible, wherever the car is street legal, that once it rolls off the dyno, I'll always confirm everything I saw on the dyno out on the street. And the number of times we'll see a subtle change in the air-fuel ratio under actual road driving conditions, or the engine may have some knock that it didn't have on the dyno. It's probably sort of 70% of the time. And I think the part that's easy to overlook is that even a quality dyno and a well-designed dyno cell, it's very difficult, if not impossible, to replicate at least the airflow, the temperatures, the real-world running conditions. And of course, we don't drive or race our cars on dynos. We race them out in real-world conditions. So when you're doing this out in the real world, it's giving you the actual conditions. One aspect I will point out, though, and I'm interested to get your feedback on this because this is something we drum into our students through our practical reflash tuning course when you're doing racetrack or road tuning. You're spending a lot of time when you're reflashing, kind of sitting on the side of the road after you've done a pull. Obviously, the engine's hot. It's heat soaking the engine bay. You'll sit there, you'll look at some log data, maybe make a small tweak to the calibration, flash that into the ECU, which may take 30 seconds, it may take 15 minutes depending on the vehicle, and then you go again. And the point I really try and drum into people is you want, before you actually go and gather some more data, you need to drive the car for a few minutes at road going speed to get rid of that heat soak and allow things to get back down to the typical operating temperatures. Otherwise, even with the compensation tables that are available, you're not really tuning under the real world conditions. Do you sort of see that, or am I out on my own here?
No, absolutely. The first thing I would hope every tuner does after they get off the dyno with the car is ask the customer to grab a log on the street real quick, because it doesn't matter how much we try, like you mentioned, that dyno is not going to provide the actual load, the actual resistance, the actual heat, the actual data that we need to see like it is on the street. And no matter how good you do on a dyno, no matter how much time you spend, that little bit of shift in how the car is loading up on the street can make all the world of difference in what cell in a table it's running out of. So yeah, I mean, it is crucial and part of the process to make sure that we have the data from the street to ensure a safe and reliable tune. And that's one of the things that e-tuning's really brought to light is, is it nice to have a dyno? Yeah, it's safe, it's controlled. You're on the dyno, you're not worrying about going over the speed limit or hitting other cars, but you don't get the data that really, really comforts the tuner in knowing that what you're putting on the car is what it needs.
Yeah, absolutely. All right. So At this point, you're using the COB platform. We've already talked about that. And with the N54 and N55 platform, I'm not really quite sure what happened in the background there, but COB sort of supported it and then kind of moved away from that. So I'm guessing you've still got customers that are needing tuning solutions. So what other options are you using?
So Cobb was great, and they sort of set the I guess they set the tone for the future going forward from about 2009, 2010 on. They allowed other companies to sort of open and expand upon what they had done. So other Flash platforms came in and created their own software suites, and instead of needing to use a piece of hardware that you had to buy from the company, now it was just an app that you downloaded on your phone, and with a quick $30 or $40 cable you got from Amazon, you were able to not only program your car, but log it and monitor it live so that, you could see boosts, and you could see if you had knock occurring. You could see if your short-term fuel trims were, getting too high, or your fuel pressure was dropping under load. It allowed so much more progress to occur quickly. And as these companies began to grow, more opportunities came for businesses like myself and like my partners to offer support through multiple platforms. We pick and choose which platforms we feel are superior or provide the best access to creating a good tune. And some are definitely better than others, but competition's good. It creates that always moving forward process or progress that allows us to always improve upon the services that we're offering.
So sort of when it comes to reflashing, there's two elements that go into this, and sometimes they're kind of an all-in-one. Actually, I'll say that again. There's three. So there's the reading and writing solution, which is generally a hardware interface, usually through the OBD2 port, that's going to go to our laptop. So that's one element. And then we need a editor software, so something that's going to actually allow us to view and edit the maps. And then the third part that I almost overlooked was the data logging element, so we see what's happening when the vehicle's actually running. Now, as I mentioned, sometimes those three components are sort of incorporated into one software package. COB's a good example of that. EQTech's another one. But sometimes we might end up using different solutions. So jumps to mind here, very common for the Subaru and Mitsubishi platform, the Tetrix 2.0 cable, coupled with maybe the likes of ROM Radar or ECU Flash for the actual editing side of things. You've mentioned this app-based Flash tool. So is that just for the reading and writing? Can you share the name of that?
Yeah, it's actually all of it. So you'd mentioned MHD and ECU Tech or EQTech. Both of those platforms offer cell phone or tablet support where you can download it in the app or Play Store and go through it that way. And it's not just the writing and reading. Those are also how you're clearing DTCs, checking readiness, monitoring in live data in real time to see what all of the different parameters are doing, collecting the data log for your tuner, allowing you to email it to them from your phone. It's everything that allows us to create the calibration as well as for them to monitor. And while the tuning changes are actually done in software on our computers, everything else pretty much is done through the phone. Okay. So it is that section comparison of what's doing what, but from the end user's point of view, everything's just in that one spot.
There's often also a bit of a disconnect here between the enthusiast market and the professional tuning market, and rightly so. What I mean by this is there's products like EQTech, which they're prohibitive at a price point for most enthusiasts if you just want to tune your own single vehicle. But for a workshop, tuning hundreds of vehicles a year obviously makes absolute sense. And then there's the other element of this in terms of, as a professional tuner, there's the IP element of your calibration that some tuners get quite caught up on. I'm not personally so worried about that. But what I was very careful of is sending my customers out with a car that's tuned safely and reliably. And then there's the concern, of course, of them having access to the calibration, making a few tweaks that they don't really understand, blowing it up, and then coming back and pointing the finger. With the strategies, the software and hardware you are using, have you got protection in place to prevent that sort of thing happening?
We do. And there's always people who, can take the file and reverse engineer it and pull it out and figure out what you're doing. It's a good amount of work to do that, but there's also people who can also look at your data logs to figure out, what are your set points? What are you trying to do? What are you commanding? And if you know what tables to look at, you can get a lot of information from those logs. But these companies have created encryptions that allow us to lock our maps, that allow us to send a file that isn't openable in Tuner Pro, that can't just be easily decrypted and modified. They have to come back to the tuner in order to make those changes.
Okay. And now you just mentioned Tuner Pro, which is one of the software packages you're using for editing, correct?
Yep. It's just an open source, free download off the internet.
Okay. Now, these software packages like Tuner Pro, they really are limited by the quality of the definition file, which I liken to kind of a roadmap. You download the raw binary file out of the ECU, which is absolutely meaningless to us in its raw form, and it's that definition file that says, all right, well, we've got a driver's wish table that's going to be this size, it's going to be at this address in that binary file, and here's where the axes are and the size of the axes. So then that piece of software can represent that table to us in a 3D or two-dimensional format as we require, so it makes sense to us as tuners. The problem is, as you sort of mentioned earlier, that there's potentially thousands, if not tens of thousands, of parameters and tables inside a raw binary file, most of which are of little to no relevance to us. But of course, there are the key tables that we do need to have good control, and not all definitions actually manage to find all of the tables we're interested in. So if you're in a situation where you don't have access, or you think there's something else missing, what do you do about that?
So I'm actually really lucky in that sense. I have been tuning for a long time, but in terms of reverse engineering or decompiling these hex codes or hex data that comes out of the ECU, it's not my specialty. But my partner Chris is unbelievable when it comes to digging through WinOls, looking for what we need and patterns that are recognized from other platforms that we've done, and creating the tables or the the sections of the ECU that we need that aren't available. So MHDs, the ECU techs, they all come out with, 95% of what you would probably need to tune a vehicle completely. There's always that couple people that you'll tune during the year that want to go far and above what everybody else is doing. And in order to do that safely, sometimes the tables aren't there. So Chris has been a huge lifesaver when it comes to calling him, at 2 a.m. while I'm working with somebody in another country and being like, hey, I can't get this to work. Find why this torque limit is getting in my way. And he'll start digging through, and 30 minutes later, he's like, try this XDF. I open it. It's got a new table, and bam, all of a sudden that torque limitation that was creating load restrictions of, let's say, a random number of 190, it wouldn't let me go over that no matter what I did. All of a sudden, here's this airflow map, and it allows me to go over that, that limitation safely. So you can tune, you can decompile, you can find these tables, but to find people who are good at both or have the ability to do the defining of the tables is very, I don't want to say rare, but it's very lucky at least. So I don't have to worry about those issues.
I think lucky is probably a pretty good way of putting it, because it is a very different skill set to the actual tuning. Having sort of gone through the learning process of using WinOS myself and the development of an upcoming course, it's Yeah, it's a scary beast to get involved with. Very daunting. I will mention some of those things, though, you mentioned there, like those load limiters can actually be surprisingly easy to find, because you can convert that to the number that you'll see in the raw binary file, and then simply search through the whole file for that number, and quite often it'll pop up and you'll say, oh, okay, well that was the load limiter that we didn't have defined, and basically from there, job done, pretty easy. Very, very vast oversimplification, but probably as much as today's conversation actually requires.
30 seconds of description for the 12 hours of painstaking work of looking at a bunch of letters and numbers.
I think I'm probably about 150 hours deep in WinOLS training at this stage, and certainly far from proficient. So maybe a little bit more than that even. All right, let's move on. So really the whole conversation up to this point has been leading to the development of Motiv Motorsport, and it's been a long-winded way of getting there, but we needed to cover the background before we could talk about Motiv. So on that note, what is Motiv Motorsport and what are you actually doing?
So we started as a hardware company back, I don't know, eight years ago now at this point. But as times changed, we saw things in the tuning world of the platforms we were involved on that worked, but didn't work right. They didn't work the way we would want them to work. And while we did what we could with what we had for so long, it really led us to finding or desiring a product that could fill a void in what we saw as a very, very important and powerful, as well as safety conscious part of the market. And that was the limitations of sort of DI fueling and having to add in port injection. And that's what sort of created our product and changed our direction of what we were focusing most on. And it was revolutionary. It was very novel. It allowed us to do what we've always been doing, but in a safe, integrated, and far more controlled style.
Let's just dive into that particular topic of the direct injected DI injection. So, I mean, most people who maybe haven't spent much time with DI engine development would think, all right, well, we're out of fuel injector, no problem. We'll just go to Injector Dynamics or any of another range of aftermarket injector suppliers and just buy some bigger injectors, right? And we'll put those in. But the fact of the matter is that that's not actually very easy in the DI world. The injectors are far more complex than a port injector, and quite often they're specific to a particular manufacturer in terms of the physical fitment as well as the electrical operation. So while yes, there are certain aftermarket direct injectors available for some platforms, it's definitely not as developed as the port injector world. So sometimes on a particular platform, really the amount of power that you can produce from that engine is going to be capped at the ability of the injectors to flow sufficient fuel, correct?
Yeah, I mean, typically it's, to throw a number out, I don't want to put out one of those numbers that everybody's going to quote, but yeah, if you're looking at a motor that's run on DI, you can typically estimate maybe 75 to 100 horsepower of fuel per hole out of direct injection. If you're looking at a 6-cylinder motor, you can support 5, maybe 600 horsepower at the crank. Just on the direct injection alone. But at some point you run out of volume, you run out of pressure, you run out of injection time because of the way that direct injection works to be able to increase more fuel into the hole. And since you can't just buy larger injectors that flow more, you've got to find other ways to add that fuel to the motor when you've hit that sort of DI limit or the end angle limit of what you're doing.
Yeah, so I mean, just a point again for those who maybe aren't sort of up to speed with direct injection. Obviously, as the name implies, we're directly injecting fuel into the combustion chamber rather than into the port. And the problem with that is twofold. First of all, these are working at massive pressures. And secondly, they have a very narrow window, relatively speaking, when they can inject the fuel. We can't inject through the entire engine cycle. Well, Well, we could, but it's not going to help us much. So essentially, you're limited to the intake stroke. So for all intents and purposes, 180 degrees of crankshaft rotation, and then some of the compression stroke, because we need to stop the injection prior to the ignition event occurring. So maybe that's 30 degrees before top dead center. So we've got sort of, in round terms, another 150 degrees to play with. So less than half of the 720 degree engine cycle where we can actually inject the fuel. So that's the two limiting factors on direct injection. Now, it's not uncommon in the aftermarket standalone world to add port injection to these factory DI engines. We're lucky enough with one of our development vehicles, the Toyota FA20, they did that from the factory. So best of both worlds, absolutely brilliant. But of course, that's not always the option, and can be very difficult to integrate that in a factory engine management system. So getting into your product, so how do you do this?
Well, previously, a lot of what we had done was just adding port injection using any controller available to us, whether it be an affordable standalone to a purpose-driven fuel controller that was specifically made just for 4 or 6 or 8 cylinder port injection control. But the problem was there was no quality solution. Nothing was available to do it in what we felt was the right way, which was to allow not only the factory ECU to understand what was going on, but everything to understand what was going on. So, you go back a few years, you were using a fuel controller, and if one of the injectors failed, or if, catastrophe occurred and you lost a ground or, your power source, that controller just stopped. But the factory ECU had no idea that it just lost 6 750cc injectors that was, supporting the extra $400 or $500, 500 horsepower that your 115 pound per minute turbo was putting work in for. And if that happened and all of a sudden you lose all that extra support, that motor's done. So did we use it for a long time and people still use it today? Yeah, but it led us to find this quality solution that was absolutely needed to really bring tuning and safety into the modern age. We have these ECUs that have multiple CAN buses that have the ability to pull, as much timing as needed between bottom and top dead center based on, sensor data like knock signals. Everything is so advanced that why not allow the ECU to see what you're doing? Why not allow that factory style integration like the ISFs or the RS3s have, where they come with port injection and direct injection, where now if something fails, or now if there's too much PI, the short-term fuel trims that are being read through these O2 sensors that are closed loop even under open or wide open throttle, it not only affects the direct injection, but it also affects the port injection. So everything is being integrated, everything is being run together, and everything is being run so that the DME or the ECUs have awareness of what's going on. They know there's 6 extra injectors. They see that there's other fueling sources, so it can cut back on the fuel volume going through the DI injectors and supplement it now with PI injectors. And, aside from the DI limitations that flow and volume and pressure allow for, DI and PI creates a really homogeneous mixture. It's really efficient. So it's not just a matter of removing the limitation of where DI runs out and you can't make more power safely, but it's also about making power better, more efficiently. DI is so great for knock control, for, setting cylinder environments up for great, consistent power. And then you have fuel coming in from the port injectors that allows you to raise that threshold of where you're going to run out of fuel. And at that point, you talk about companies like ID, the sky's the limit. It really allows you to not have fueling woes. And by combining the two, now you're having the best of the DI and precise injection for your daily driving, like we discussed earlier, where it's smooth off the line. It starts up every time. It runs efficiently. You've got great gas mileage. But get on the throttle, PI kicks in, and everything communicates well together. And now your car has endless amounts of fuel for whatever power you want to throw on it.
Okay. A lot to digest there. Sounds like a really advanced solution to a pretty tricky problem. So you've mentioned CAN bus. I'm taking it that from that you've got two-way communication from your device to the factory ECU.
We do.
Now, obviously, in stock form, that factory ECU is not going to be expecting any messages from your device, and certainly sure as hell isn't going to know what to do with it.
Yeah.
I'm right here in assuming that this is going to require some modification to the factory ECU code as well for these two devices to work together?
Yes. So, when we start on platforms, a lot of our customers and companies that request our products use it as a tool that's added on and tuned through the Reflex to add these features. It's not integrated quite yet at those points. But as the development continues, we start integrating things like sensor data being sent to the ECU so that if an injector fails, the ECU can be thrown into a limp mode or a torque limit or a cylinder fill that prevents any damage from being done. And then to further expand on that, then they start with two-way communication. Now they've started sending us signals from the DME, whether it's added tables that they've created or custom logic that allows them to control outputs that weren't there from factory. For example, like the port injection, these guys can now control them from the factory ECU. So everything is closed loop together and everything is monitored and adjusted and, functioning all simultaneously under one set of controls.
So proper integration as opposed to piggybacking, which we've talked about numerous times so far. From a tuning perspective, how are we handling this? Are we now dealing with two pieces of software? Am I reflashing the factory ECU? Obviously, the factory ECU is still in control of our ignition advance, even above and beyond the limitations of the factory DI injectors. So obviously, I expect we're dealing with that element there. Do I then use your own bespoke software for tuning the port injection side over and above the DI? And how does that smoothly integrate?
So it really depends on how the customer is using it themselves, as well as what the flash platforms on that vehicle are capable of doing. At the very beginning, when we start development, everything is done through our software separately as sort of running in parallel with the factory ECU. We can control all the injectors. We can control 4 outputs. We have sensor data coming in over 4 inputs. We have flex fuel built into it, so it automatically adjusts for real-time content. But as things progress, we can start taking control away from the Reflex, and it can work in a hybrid situation where the ECUs have some control and we're sending data to the ECUs, all the way to the full integration where the Reflex becomes a slave and everything is within the ECU, and what the ECU tells the Reflex to do goes out to the different sensors and out to the different modifications, whether it be a pneumatic solenoid for boost control, fuel pumps, nitrous, methanol, line locks. The sky is really the limit on what we can control when working with these companies that have the ability to modify the logic and add tables to the ECUs.
Okay. In terms of if we're programming the Reflex from within inside the Reflex, I mean, obviously it's going to be quite important for good control of the air-fuel ratio through the various load and RPM ranges you're operating in. It's going to be important to match the load axis and the Reflex to the load axis that the factory engine control module is using. And in the standalone world, we're typically almost exclusively manifold pressure versus engine RPM, whereas that's not always the way in a factory engine control module, or seldom is the way. We might be talking about relative load percentage or something of that nature. So how do you deal with that so that those two stay lined up?
So it really depends on how the customers set it up and what that platform has. For the guys that are starting earlier than development has begun for the flash platforms, we tap into the map sensor, we tap into the crank, we tap into the cam so that we can do sequential injection. Up until this point, all these controllers were just doing batch fire, firing 4, 6, 8 cylinders at once. which plays a huge effect on fuel pressure and sort of keeping things consistent. But using the raw analog signals from the map sensor and calculating crank and cam based on the pinouts that we pull, it allows us to match what the DME is doing in terms of RPM. We know where exactly we are on which stroke because we have the cam signal as well as the crank signal. We know where we are negative or positive pressure because we're pulling in that voltage from the map sensor and scaling it properly. As the platforms develop, though, we're still controlling the frequencies that our outputs are doing and how we're interpreting the crank data and how we're interpreting the cam data. But the commanded duty cycles or the on-off signals are coming from the ECUs. It allows us to make sure that we're always in sync using those analog signals. Now, on MHD and Ecutech, we have the ability to pull that data over CAN bus as well. So, we can also double check our calculations based on what's coming in over CAN and what we're getting from the raw analog signals. So we are always doing these sort of self checks that are counting down. Like if you look in our software, you'll see we have timers that are going on. And every time these timers go around, we're making sure that everything's in sync. We're making sure that, yes, we're still at the right appropriate place for RPM based on, are we on the intake stroke or the exhaust stroke? We're not just looking at where we are on the crank. So we are constantly able to make sure that everything is precise and matched up with what the car is doing.
I can only imagine, particularly if you're running this as essentially a standalone product with little integration with the factory engine controller, that is there some sort of, how would I put it, maybe trickery that you need to do to the factory engine control module to basically limit the maximum injector pulse that's being sent to those direct injectors, but also at the same time allow it to understand that it's going to go above and beyond what the typical airflow limits would be calculated to be with that injector?
When we're controlling the system from the Reflex as opposed to being fully integrated and controlled by the DME, we're able to set up injection time through our tables. So we offer off-the-shelf maps on our website that allow people to download, hey, I've got a BMW M3 with an S55 engine and I bought these 750cc injectors. We offer tables or maps that you can download that have, obviously it might need some checking and tweaking because every injector flows a little bit different, but we offer maps that are pre-set up for a lot of these tables. And once you get into the integration side of things, you can set dead time. You can set all these different factors that allow you to calculate how much fuel is going to be needed and set limitations on, where we're going to end, how much DI is pumped versus how much port injection is going through. You can set these end angle limits so that you set where the fuel is going to come from so that you don't run into those issues and it's not a concern.
Okay. In terms of the platforms that currently offer full integration, I mean, obviously you're going to work with what you've got available. And if you want to make more power in an engine platform where the aftermarket reflash solutions don't currently have integration, well, have at it. You're going to be tuning on the two different platforms to get the result. Fine. Yeah. But I mean, in the ideal world, obviously, it would be nice to be able to do all of your port injector tuning from the same software you're using for flashing the ECU. So currently, can you sort of let us know what platforms are supporting that?
Sure. So we developed it. Ty, who's our electrical engineer and head of development, has a very extensive background in CAN bus development, CAN bus programming, design, implementation. So we are very fortunate in that we don't have a lot of roadblocks that he can't overcome. So he has created sort of a template of what we send out and what we're looking for to get back from ECUs. So as soon as we get the request from customers or get the request from companies that have platforms that they want to be supported, we send out a questionnaire and a file that outlines what we want on what bit and what byte and what we're going to send out and what we expect to receive so that both sides of communication are on the same page and we're transmitting over the correct addresses. we can't use fixed addresses because on one car it may be available, but on the next car it's going to be communicating on the same channel something else is. Yeah. I mean, just as a simple example, we have people complain all of a sudden on a new platform that their dashboard is flickering because it's a simple address. So we adjust on our end as well, but it's pretty much a templated situation. And the first two companies to do it were ECU Tech and MHD. So with them, it's been sort of a staged approach, as I mentioned earlier, where we had worked with John Visconti, and he had been doing this straight through the Reflex and trying to get support from ECU Tech to bring it along. They saw how well it was doing and came on board, and they created their integration. So as time went on, it didn't start, Rome wasn't built in a day. It didn't start all in. They started with signals, then they started with port injection control. Now they're controlling outputs like boost control and nitrous. And we've got Supras that are launching on nitrous, getting out of the hole quick enough. And there's no controller aside from the DME. I mean, you're literally programming nitrous to get you out of the hole through a factory DME as if it came on the car stock. It's awesome. And these companies like MHD and ECU Tech, and now some of the Audi platforms are getting in. And we're working with some other tuning platforms on expanding these integrations will be limitless once it does develop and expand on those. We just want to get to more platforms and create this ability to have such a reliable and safe way to make that extra power. And using the Reflex as this expander to the factory ECU provides so much flexibility and extensibility that, the flash platforms would be even more powerful if we could, get more people involved in it.
I guess it makes sense that as the platform becomes more and more popular, more people are trying to make power at a level that requires a product like the Reflex, then it makes sense that slowly but surely the reflash manufacturers or companies are going to get on board. And the ability to use it as essentially an auxiliary I/O box over CAN, again, just massive expansion on what can be done. I'm guessing from your perspective as well, other than, as you mentioned there, the sort of requirement on a floating base CAN address, essentially you've got a flexible product that's applicable to absolutely any factory platform, or is it a little bit more application specific?
No, it's pretty open to whatever. The sky really is the limit. We're really lucky that our staff and some of the owners of the company have such a variety of skills, and we all work so well together that, we haven't run into an issue that we haven't been able to solve, not only on time, but overnight. Sometimes people are just shocked. They report a problem to us, and by the time they wake up in the morning, they've got the firmware update and it's good to go. And the way it's designed is, any flash platform on any vehicle, as long as they have the ability to, create custom logic, create tables, and communicate over CAN, we can do just about anything. We can multiplex, so we can have multiple CAN messages that are cycling through different sort of menu options based on what the first or second byte are, calling for. We can have endless. I don't want to say endless. We can have a very large amount of data that is transferred back and forth near instantaneously without worrying about having extra addresses. So it's really a sky's the limit sort of situation with what we can do, as long as the flash platforms that we're working with are able to put in the work and do the logic on their side as well.
Okay. Now, you've just mentioned the sky's the limit, and this is a topic that always comes up, is sort of at what point are we beyond what we can do on the factory engine controller, and at what point does it make sense to move to an aftermarket standalone? Now, that in and of itself is a complex question, because as we alluded to earlier in the chat, as cars have become more complex, just getting rid of the factory engine controller and fitting a Motec or a Haltech is difficult, and in many instances absolutely impossible without some very specific integration work. But for popular platforms, there are plug and play options that have been developed around that. So at what point do you sort of go, yes, this is the correct option. I mean, obviously you've got a dog in this fight with your own product, but I mean, trying to be a little bit objective of the situation,
Absolutely.
is there a limit on what we should be trying to achieve with the factory controller?
Absolutely. No, I in my years, I've run with standalones from motorsport grade to consumer grade products, and I absolutely love tuning standalones. You're not tuning around factory nannies that are in your way and trying to find them just to get that extra pound to boost. You're setting up the environment yourself. But the problem becomes that on modern day cars, with all the CAN bus systems and the integrations, it's not as easy as just plugging in even motorsport grade ECUs, especially with the integration of like FlexRay in a lot of the newer cars. FlexRay is beyond difficult to crack and come in from an aftermarket perspective and communicate with. So in all of these vehicles that have FlexRay, a standalone is going to be real difficult to fully remove an ECU and replace it with a all-in-one package.
For those who haven't heard that term FlexRay before, that's, for want of a bit of a term, the OE world's next generation of what CAN bus currently is. Just a very different protocol. And I'll admit I'm definitely not a specialist on FlexRay, but at a sort of a high level, is that a reasonable kind of description of it?
That is putting it nicely. Yeah, it is. It is even for the most advanced aftermarket. I mean, it is just a very complex bus to get in and communicate and not cause issues with.
Yeah. Okay.
So, there are ways of doing it and working around and running a standalone in parallel with an ECU to keep things happy. But what population of our, market is going to go that route? Are we looking to tune cars that are, doing wheel to wheel racing and, trailering their vehicles across the country to different road courses? Or are we looking to tune, the everyday consumer? And the majority of the population that we serve is that standard consumer who just needs enough. They don't need every bell and whistle that a standalone would provide. And we can create expansion units to have more outputs and inputs. But at the end of the day, the percentage of people that are going to really utilize all that extra technology is very small.
Sure.
So is there a need for it? Yes. Is the demand for it high enough? I would love it to get to that point. I mean, I enjoy seeing the market grow. I enjoy seeing technology change, and I enjoy seeing how we're defeating a lot of the restrictions that are put in from the OEs. But at some point, if you're going to be running time attacks, a standalone might be it. You might need that better traction control system. You might need those other things. But like I said, for 99% of the community, we are developing this product for them.
Okay. Well, let's get on to some of the results. And I mean, we've talked about BMW so far, so it's sort of a slight tangent. We'll talk about the A90 Supra, which, of course, as everyone knows, runs the BMW engine anyway, the B58, which has become an incredibly popular tuning platform. And as usual, there's some pretty heated competition, particularly out on the drag strip, between different tuning shops running the A90 platform. Your product has become pretty important to a number of them, I understand.
Yeah. So I would say, if you're the A90 Supra definitely was a huge slingshot into success for us. Having so many of these guys tuning all of these cars and all recommending the Reflex because of its ability to control port injection and pneumatic wastegates and nitrous and methanol and everything all in one go. It's been really revolutionary and pushing that platform forward and it growing so fast. And that is the perfect example. We were talking about FlexRay, the A90 Supra was one that a lot of people wanted to throw standalones on, but because of FlexRay and it just became difficult. But, over the last 2 years, we've seen 2 Texas 2Ks, Florida 2Ks, the meet in the middle events. All these guys that are pushing deeper and deeper into the eights I can't say all of them, but I would say 90% of them are using a Reflex. And the community is really close. They all work together. They all talk. They all go over what works and what doesn't. And it allows us to work with these manufacturers like ECU Tech and MHD to really push that platform faster and further forward.
So obviously, in terms of power capability, it's really going to be limited by turbocharger, engine component strength, and ultimately the size of the port injector that someone chooses to fit. But I mean, what sort of numbers have you heard thrown around with people running that platform on your Reflex product?
The guys that are running deep into the eights are in the 900 probably to 1100 horsepower range.
Okay.
If the Supra's DI injection alone can support, let's say, 550 horsepower without port injection, we're only supplying another 500 or 600 horsepower of direct injection fueling. So, an ID 1000 or an ID 1300 or whatever injector people are using is pretty much large enough to get you up there, because you're not, you think of it as like a dual rail where you've got two sets of injectors. You don't need the largest injection out there. You want something that can control it pretty precisely. So, these guys are running 1000cc injectors. And although we don't know their exact horsepower figures, because, face it, none of them will really go over or show results before the events because it's competitive. You can sort of estimate, knowing what turbo they have and how much boost they're running and, what times they're running, approximately how much power they're making.
The mile an hour is always a pretty good dyno. That generally gives you a pretty good indication of what someone's making. You've mentioned deep in the eight, so obviously this is a moving target depending on when people are listening to this. But at the time of recording, can you let us know sort of what the current record is on the quarter?
Yeah. So going back to like November, we were presenting at SEMA, and we were really excited. The Adonis Auto car I think it was running about mid 850s at that point. And we had a video showing in our booth of it, setting that record. And we got a call mid SEMA that was like, hey, and it was the same person that built the car. P-Tuned had just reset the record at like 849. So, and he runs a Reflex as well. And it was tuned by Jeff Payne, who's the same guy that tuned the other car. Every week or every month, somebody is resetting that record, and they're pushing farther and farther and farther. And it's fun to see the community getting together, especially around our product, being that we've put so much time into it and seeing how it's helping advance. It's great. I think the record's at like 843, 844 right now. And I wouldn't be surprised now that it's sort of race season again, and at least in the States, we're getting out of winter and into spring. It's boost weather. I would not be surprised to see somebody come up with an 8.3 somewhere in the 8.3s pretty soon. And then again, followed up by somebody getting angry that they took that record and pushing it even further. That's what drives us, is that friendly competition.
Yeah, absolutely. I think that's the one thing with a platform that's popular, is that if you're racing in isolation and you're just racing against yourself, there's really not as much desire or pressure to sort of raise the bar. But when you've got a record and someone takes it off you, you're pretty keen to sort of jump back and pick that record back up. So
yeah, we've all watched that GTR battle and the now the R8s and the Huracans going for all those times. It's the Supra. Hopefully with the Reflex on there, the Supra we'll see 7-second passes this season.
Yeah, I look forward to it. All right, Jake, I think we'll move towards wrapping this one up. And we've got the same three questions we ask all of our guests at the end. And the first of those is, looking into a crystal ball, what have you got on the radar? What's sort of upcoming for Motiv in the future? Or what directions are you heading?
Good one. So we've got some really cool stuff on the way. It's been a struggle through the pandemic and supply chain issues to sort of keep up with just where we are. But we are really intent on expanding the Reflex line of parts. Having the ability to do a lot over CAN bus allows us to have remote I/O boards, user interfaces, gauges that over CAN are communicating back and forth. You can do adjustable settings on the fly using these touch screens, and everything is over CAN bus. So it's all still integrated with the factory ECUs. We've got a couple other products that we're not really talking about yet, but will expand on the Reflex line that are just as novel as the Reflex was when it started. And we look forward to getting those out this year to the general public so that we can sort of share on our excitement of how we're making aftermarket performance more integrated and safer and more reliable for the end user.
Oh, perfect. All right, looking at your sort of career path so far, getting to where you've got to at with Motiv Motorsport, if you could sort of go back in time and maybe give some advice to a younger version of yourself, or maybe our listeners who are maybe considering a similar path, any advice you've got that might help fast track things or avoid pitfalls that you've had to live through?
I've always, it's a question I get a lot. I always go to collaboration. I would not be able to do what I do without the people I work with. Chris and Ty are beyond, it's hard to do what we do without the support of each other, and without our skill sets and how well we work together, we wouldn't be here. So my advice would be find the people that build you up and you work well with, collaborate, share your experiences, because when you work together and when you have those people around you, not only does it make it more fun, but you have the ability to bounce ideas off each other and expand your knowledge faster and quicker. And I would always say, be willing to be wrong. Learn from your mistakes and use that knowledge to make yourself better for your customers.
Yeah, that's great advice. A couple of things I'll point out there. Just you mentioned about not being afraid to be wrong, and I mean, unfortunately, I think sort of inground into us as humans, right from birth and through the education system, is that making mistakes is bad. The reality is that we're kind of pre-programmed to learn from making mistakes. So it's kind of a natural sort of progression, I believe. So yeah, I 100% agree. Don't be afraid to make mistakes. Unfortunately, when we're dealing with 1,000 horsepower engines, sometimes those mistakes can end up being costly. But
they can. And another piece of advice would be make the mistakes on your own car. Don't learn on somebody else's, because that's how you get a bad reputation real quick.
Yeah, absolutely. And the other point again, collaboration. I think too many people believe that they have to do everything themselves, and the reality is you can't be an expert in every field, and particularly with what you're doing. Obviously, it involves a lot of different elements. So bringing in the smartest people in their respective areas, absolutely the way to fast track your progress. So really good advice there, Jake. I appreciate that. Last question for today. If people want to find out more about Motiv Motorsport, the Reflex product, etc., where should they go to?
We are working on our marketing abilities. I would say that we are more focused on creating a great product than we are marketing our great product. But we are pretty responsive in terms of like Facebook and Instagram. You can email us at the sales@Motiv Motorsport, or support at Motiv Motorsport, or even Jake, Ty, or Chris at Motiv Motorsport. But go to motivmotorsport.com, take a look through all our stuff. We've got technical sections that are going to be added. We're going to be adding more blog posts. And if there's anything you don't find on the website, reach out to us, because we're always happy to sort of discuss what we do. It's great. We love this stuff. So being able to talk shop with customers it's actually kind of fun. We look forward to it.
Perfect. Oh, it's definitely a novel and interesting product, and I really like the lengths you've gone to with that integration with the factory ECU, which is an element that is difficult but is going to pay dividends. So great to chat with you, Jake. Thanks a lot for your time today, and we appreciate you coming on board.
Oh, I appreciate your time. This was absolutely a blast.
All right, that concludes our interview. And before we sign off, I just wanted to mention, for anyone who's been perhaps hiding under a rock and hasn't heard of High Performance Academy before, we are an online training school, and we specialize in teaching a range of performance automotive topics, everything from engine tuning and engine building through to wiring, car suspension and wheel alignment, data analysis, and race driver education. Now, remember, you've got that coupon code. You can use podcast75 at the checkout to get $75 off the purchase of your first course. You'll find our full course list at hpacademy.com/courses. Important to mention that when you purchase a course from us, that course is yours for life as well. It never expires. You can rewatch the course as many times as you like, whenever you like. The purchase of a course will also give you 3 months of access to our gold membership. That gives you access to our private members only forum, which is the perfect place to get answers to your specific questions. You'll also get access to our regular weekly members webinars, which is where we touch on a particular topic in the performance automotive realm. We dive into that topic for about an hour. If you can watch live, you can ask questions and get answers in real time. If the time zones don't work for you, that's fine too. You're going to get access as a gold member to our previous webinar archive. We've got close to 300 hours of existing content in that archive. It is an absolute goldmine. So remember that coupon code podcast75. Check out our course list at hpacademy.com/courses.